Welcome, everyone. I think we're 2 minutes early, but I think I'll start anyway because I have a lot of things to show you. So, all right. Cool. So welcome to this presentation. My name is Laurent Bugnion. I work for Microsoft since August. Before that, I was working for another firm called Valorem. And Valorem was one of the first agencies to work with Microsoft to develop HoloLens applications. And so we have quite a past. Since 2015, more or less, this firm has been developing production applications, proof of concepts, all kinds of things, and really pushing the limits of what can be done. So here you will see HoloLens 101. This is for pure beginners, right? So if you have never seen HoloLens work, if you have seen it, but you don't know how to program for it, if you don't know what a vector is, that's the right place to be. If you know all that, later, right after my talk in Homo sapiens, my ex-colleague from Valorem, René Schulte, is going to give a 301. So he's going to be going quite a lot deeper into HoloLens development. So if you do both, then you graduate at the end as a wannabe HoloLens developer, okay? Cool. So before we move into code, I want to precise a few terms because there are a lot of things floating, VR, AR, MR, and what do they even mean, right? So now I'm going to talk about virtual reality. So virtual reality is something which is fully immersive and fully occluded, meaning that you wear a headset, for example, Oculus Rift, HTC Vive, and those devices hide the real reality, notice the air quotes, real reality, and you don't see anything around you, and then you need to rebuild a reality from scratch, and you need to rebuild everything, including the floor, the walls, everything, right? And so, of course, you need quite a lot of power to do that. So these devices typically are cabled to a computer, and the computer needs to be a little bit beefy. You need a little bit a good graphic card, good RAM, and on the other hand, the cool thing with that is that you can really create new worlds. So you can put people on Mars, you can put people in space, in old pyramid, in Indiana Jones, whatever. And that's a cool experience. It can be also a little bit weird because, first of all, if the computer is not good enough, if you have less than approximately 20 milliseconds, if you have more than 20 milliseconds latency, meaning that if you turn your head and the scene doesn't react immediately, you can get sick. You can get motion sickness, which is a really, really bad experience. Believe me, I almost had that, and you don't want to barf in the office, typically. So that is really something you need to think about, right? As a developer, you need to be careful that your scene is reacting really fast, and after that, the user has to have a good PC. That's the first thing. The other thing which is a little bit weird with these devices is that you're totally cut from the experience. So if you have somebody next to you, if the developer worked really well, maybe they will detect and then do an avatar, but that's pretty complicated. And also the avatar, you have what we call the uncanny valley. So when they talk to you, it's kind of weird. And maybe you just don't see the person next to you, and so you're speaking to someone that you don't see. Experience made, it's a little bit weird, but pretty good devices anyway, pretty good experiences. You can get those for a reasonable price, so I recommend you to try it out. Now, of course, you also have another type of experience in VR, the really, really, really cheap one, cardboard, for example. There is also Samsung Gear, which is a little bit better built, where the experience is driven by your smartphone. So if you have a good smartphone, you're going to have an okay experience. If you have a cheapo smartphone, then you get what you pay for, right? But the good thing with those devices, though, is that they are really democratizing VR for everyone. Everyone with a smartphone can try it out. And so that's actually an advantage, okay? So you have some fun experiences with those things. I started seeing people in the plane with the Samsung Gear and watching a movie. And honestly, the plane is like the best place that I want to be isolated from people around me. You typically don't want to see the guy next to you in the plane. So I guess that would be a good use case. Now, Microsoft started partnering with OEMs, for example, Acer in that case, or HP, and releasing some virtual reality headset. So just to be clear, those are not HoloLens, right? Those are virtual reality headsets. They are cabled to a Windows 10 computer. And you also have controllers on some of those, and you can have a virtual reality experience, fully immersive and totally occluded. And you can get some really cool experiences here. Okay, so augmented reality is, you probably all saw that. And in fact, even my dad in the day saw that because that's really augmented reality, okay? See a football match, it's filmed by camera, and then you add some information, and so you augment the reality by adding some information. Nowadays, you can have some really cool effects where they have an arrow pointing to a player and then following around, etc., etc. Very simple. Of course, when we talk about augmented reality, we're rather seeing about something running on a phone. And of course, on the phone, you can take advantage of the sensors. For example, GPS, accelerometer, compass, so that you know where you're looking for, you know where you are. And so this is, on the old Nokia, we had this type of experiences where you could be in New York and say, okay, I want to eat somewhere. Where do I have a restaurant? And then moving around, oh, I have a restaurant here. You click on it, and then you get details. Another such application, I was pointing it to the sky above my house. Here it's overcast, so you don't see them, but there are planes flying around going to Zurich. And you can get the information about the plane, where are they going, how high are they, etc., etc. So some fun experiences where you take advantage of the phone sensor. Of course, Pokemon Go. I guess everybody who has kids who were kind of teenagers or maybe younger last year knows what I'm talking about, right? Because it was really a craze. And Pokemon Go is an interesting use case, interesting scenario, because first of all, it shows that the devices that we have in our pocket are ready, slowly ready for this type of experience. Battery life in Pokemon Go was kind of hard, right? I mean, it was really draining quite fast. But still, I mean, you have GPS, you have accelerometer, you have the camera, which allows you to place the holograms in the real world. And also the fact that society is finally ready for this type of experience, right? I mean, when you saw the videos, maybe like I saw one in Seattle where people were really literally stampeding around because there was a fluffy goon or whatever the name was, running around, then it was pretty impressive. I mean, it was really a phenomenon of society, right? So that's quite interesting. So now when you talk to people about AR, maybe they don't know AR, but when you tell them Pokemon Go, they know what it is, right? So society is starting to be ready for that. Now let's move on to mixed reality. So mixed reality, the way that Microsoft describes it, and before them there was some studies and some papers around that, it's really a spectrum. So it's really a continuum if you want. So on one hand, you have physical reality, and augmented reality uses the physical reality, the real reality. On the other hand, you have digital reality, which is totally recreated from scratch. And this is where virtual reality lives on. And when we speak about mixed reality, it goes from one way to the other. Okay, so we have some mobile phones which can handle digital reality, like fully immersive, and then we have mobile phones who handle AR, augmented reality. HoloLens is rather on the side of AR, and the Windows immersive headset, like the Acers that I had before on the picture, are rather, on the other hand, on the digital reality side. And then depending on the application, they are placed on the continuum, if you want. Pokemon Go, clearly AR, okay? 360 video, you're really totally immersed, so you want to be cut from the reality. You don't want to see the reality around you because this is going to disturb the video, okay? On the other hand, if you have things like Fragment, for example, Fragment is a game running on the HoloLens. I don't know if you tried it, it's pretty cool. It is really taking advantage of the environment. So anecdote, I was in my office once, try Fragment for the first time, and my chair was in the middle of the game, of the scene, my real chair, right? And then suddenly there is a character sitting on my chair. And this is really awesome because it makes you feel like, oh my God, this is real, right? Fragments is even a little bit disturbing because this is a game where you need to solve a kidnapping, and you see some scenes like a guy shooting very close from a kid's head, which in my own office, right? That was really kind of weird. So it can really enhance, I mean, taking advantage of the space around you enhances the experience, all right? On the other hand, you have, for example, HoloTour, which is an interesting scenario. HoloTour is really an augmented reality, it is really a virtual reality application because you see a film, right? So HoloTour, for example, you're placed in Rome on the Piazza Navona, I think, and then you see the fountains, you see people walking around you. So ideally, you don't want to see your sofa, right, on the Piazza Navona. It doesn't make sense. So you can play HoloTour on Microsoft HoloLens, and you can also play it on the immersive headset, which is probably a better experience. But this type of application, the so-called VR application, sometimes makes sense on HoloLens because on HoloLens you can also have collaboration between devices. I'll show you an example later where I'm walking into a plant, a chemical plant, an industrial building. And so, of course, if I'm walking into it, it would be better in VR. Okay, so walking in VR is dangerous because, oops, suddenly there is a step here and you don't see it, right? But on the other hand, I could have my colleague with a HoloLens who sees the same scene than I see because the devices can collaborate. And then in addition, we can talk to each other and then we can take notes, for example, right? So again, there is a continuum and some applications make more sense on one device or the other. But basically, sometimes it's interesting to have both. So HoloLens is a device which takes great advantage of spatial features. Spatial mapping, you might see, I don't know, it's a bit far, but I'll show you a video later. Here you have some Kinect devices. There is one on each side. It's miniaturized. And those are going to map the room and know where is the ceiling, where is the floor, where is a chair. It doesn't know it's a chair. It just knows it's a surface on which I can put a hologram, for example. Okay? So spatial mapping, super important. Spatial audio means that since you're immersed into the scene, if you have something happening behind you, maybe as a developer you want to warn your users to look behind. So I can actually put sound in a location, and if you turn your head, you will hear the sound coming from that location. Or you can have sound moving through the room, for example, a dog running and barking, these kind of things, right? Spatial audio is pretty awesome. It can be super scary also, depending what kind of sound you play behind the head of the person. But that's another story. So HoloLens is great to scare people also. All right, so on the device you have a CPU, okay? You have a GPU, and you have an HPU. HPU is a holographic processing unit. And basically this is what is going to calculate how the hologram should be placed on the lens so that the brain believes that they are real. And it does a pretty good job, actually. This is quite impressive. It's also fully untethered. So in the contrary of Oculus Rift, HTC Vive, which need a cable, this one doesn't need any cable. It is fully embarked. You can walk around. You're not hindered by anything. Battery life is pretty good, quite a few hours, in fact. And so you can really use it in all freedom. And finally, it's a Windows 10 computer, meaning that you have access, for example, to your OneDrive account if you want. You have access to your I don't know, your Twitter account, etc., etc. Windows 10 applications, the so-called Universal Windows Platform application, run on HoloLens. They run as a billboard. I'll show you an example later, like it's floating in front of you. And you can absolutely use them without any modification. And then in addition, you have the immersive application, which are fully 3D, which we'll talk about in a moment. All right, couple of videos here. So this is a sensor that I showed you before with a small Kinect for the spatial mapping. Here you will see the lenses and the HPU, which in itself, I'm told, represent a good portion of the price of the device. It's quite a complex part. And then you have, of course, the speakers for the spatial sound. All right, in terms of development environment, so this is a Windows 10 device, which means we are going to use DirectX to create the 3D, okay, like all Windows devices. Now, DirectX, you can code for it. For example, in Visual Studio, you can code for it using C++, if you like pain, and performance, right? So if you want good performance, some people really code straight to DirectX using C++, and then you'll get the best performance ever, of course, because then you go straight on the metal. But most people don't do that. We like middleware. We like a little bit more comfort. Unity is a good example of a middleware, which works great with HoloLens because they have an SDK. They partner with Microsoft quite closely. But in theory, you can take any middleware which renders to DirectX and create your applications like that, with a little bit more manual work, maybe. Now, you need content. Content can be created from scratch, for example, by digital artists. So we at Valorem, or they, I should say, since now I left the firm, have digital artists on staff, and this is really important for this type of application. You want good content, and you want performant content. So content can be obtained from clients sometimes. For example, they give you an AutoCAD drawing of an object, of a chair, let's say. Well, experiments made, those AutoCAD drawings are way too complex for the HoloLens to handle. Too many polygons. Okay, so at some point, it's going to render slower and slower, and that's a bad experience for the user. You don't want that. So then we partner with digital artists to actually reduce the number of polygons. There are quite a few ways to do that. For example, there are some applications which can do that automatically, but then they tend to leave holes in weird places. So then you need an artist to go and fix that, typically, okay? So content can be created from scratch as well, or you can also, for example, use 3D cameras to scan something, and again, the model is probably going to be too complex, so then you work with an artist to simplify that. And then you create textures, okay, you create lighting, basically you can fix the model to make it look really good, even though it is a little bit simplified. Okay, so I'm going to show you a demo, and we're going to build a super simple HoloLens application, just so you get a feel of how the development process goes. So in order to do that, I'm going to switch to Unity. And here I created just file new project. That's what you get. Now the first thing we are going to do, I'm going to get rid of the light. Why don't I want light? Well, simply put, this is a mixed reality experience where I'm going to use the real light of the room, and so I don't need additional light. Now if you want to put a spotlight on an object, on a hologram, because you want to attract attention to that object, you can do that, obviously. At some point, you switch the light on, the object is going to shine a little bit better. But in general, for the ambient light, we just use the light around us, okay? So let's remove the light. Then we are going to worry about the camera. So the camera is going to be on your head. This is a HoloLens, it's a camera. So we are going to start by putting it in 0, 0, 0, which is the origin of the world when we start the application. Okay, so 0, 0, 0. And then after that, when you move your head, the holographic SDK is going to transmit this information to the application, and the scene is going to be modified. You don't need to do anything there. The next thing I'm changing is changing the skybox. You see, now it looks a little bit like the sky, okay, and the horizon. We don't want that because it's going to feel weird if I have the skybox. You know, I want to see you guys. I don't want to see a skybox in front of me, right? Again, it's immersive. So I'm going to remove that, put a solid color, and I'm going to choose the color black. Why black? Well, the holograms are made of light, and black is absence of light, which means that black appears transparent on the device. It's actually kind of a limitation. If you have black text, you can see through. Okay, so you need to be aware of that. The HoloLens cannot render the color black. Okay? So in that case, if I do a black background, I'm going to see you guys instead of the background. That makes sense? Black is no light, and so that works. Cool. All right, another thing we can do, here we have the clipping planes. So clipping planes means we are going to stop rendering the holograms when it's closer than, in that case, by default, it's 30 centimeter. 30 centimeter is a little bit close for my comfort because my eyes are going to start crossing, and you really don't want to see that. Okay, and you don't tweet that either. So I'm going to just change that to 50 centimeter, okay? Like this, when I'm closer than 50 centimeters, then we'll start seeing inside the hologram if you want. So like this, my eyes don't cross. And here, 1,000 meters is way too far, okay? So I'm going to reduce that to 100. It means that anything further than 100 meters from the camera is not even going to be rendered. And like this, we save performance because of that, okay? Even 100 is already pretty far. When the holograms are far enough, you almost don't see them anymore. All right, now I'm going to place a container. By the way, you see I can navigate on the scene. I can move it around, all right? I'm going to place a container in the scene, and I'm going to use this container as like an anchor for my objects. So I'm going to right-click and select Create Empty. Now, the really fun thing is that it calls that a game object, because Unity is a game development platform, and we kind of misuse it to do serious work, okay? So we have game objects everywhere, which is fun. I'm going to rename that container. And then this container, why don't I see it? Oh, here it is. Interesting. I'm going to put it 0, 0, 0, and then I'm going to move it a little bit in front of the camera. So basically about 2 meters in front of the camera. Now inside this container, I'm going to put some content. And I'm not an artist, but I'm really good, really good at drawing cubes. Here we go. I can even do spheres, but that's more expensive. So here I have a cube, and this cube is really big. It's like 1 meter in size, way too big. Okay, so I'm going to reduce that to 20 centimeter, 0.2, 0.2, 0.2. All right. And then I can see the game. You see, this is here what I see with the camera. So now what I'm going to do, I'm going to rotate that cube a little bit. Let's move in a little bit closer. Let's rotate it like that, just to make it a little bit more interesting, all right? Now this cube is very gray. I'd like to give it a color. So what we are going to do is create what we call a material. To be clean, I go to my assets down there. I create a new folder. Let's call that materials. Then inside the folder, I'm going to create a new material down there. Now, materials are pretty complicated. I'm calling that cube mat. And so, basically, you have a base color, then you can have some texture on top, then you can have some lighting. It's a 1 hour talk in itself. So I'm not going too deep here, but I'm just going to change what they call the albedo, which is like the base color, and put it to red. And I can drag and drop this material on the cube and make it red. All right? Now, another thing I want to do with the cube, I'd like this cube to react with the real world. So I'd like some physics. So one thing I have here, you see in the components of the cube, I have a box collider, meaning that the cube is going to be aware of other holograms. It's going to collide. That's already a good start. But in addition, I'd like this cube to react to gravity. So I'm going to add a component, select physics, Rigidbody. That's basically physics, okay? Now, by default, Unity uses Earth physics, which is good for us. If you want to do an application on the moon, you need to change parameters. And here I'm going to remove the gravity, because at first I want the cube to just float. And then we'll switch on the gravity in the application, all right? Cool, so now I have my cube. Now I would like to be able to select the cube. In order to do that, I need a cursor. I need to know where I am looking at, okay? So I'm going to, again, I told you I'm really good at cubes. I'm going to create another cube, but this time on the main camera. This is going to be the origin of this guy, if you want. And I'm going to call that cursor. Now, this cursor here is way too big, so I'm going to make it 3 centimeters. Oops, 0.03, 0.01. Let's look at the cursor. Of course, I could have any shape I want. Typically, on HoloLens, we use some donut, right? So it's a dot, and then when it sees your hand, it turns into a donut, which is a good feedback. Here, very simple cursor here. And the other thing I want to do here, I'm going to remove the box collider. Why remove the box collider? Well, you see, we are doing physics here. If I have a box collider, and I have my cube, and I have the cursor going on the cube, they are going to interact. So basically, the cursor is going to push the cube. But now comes Newton, action-reaction. The cursor is really small. So basically, if it pushes the cube, it's going to be pushed back, and then it's going to fly at you because the cursor is super light, and the cube is quite heavy, right? So the cube is almost not going to move, and then the cursor is going to fly straight at your head, and you're going to be very scared. Experience made. So I'm going to just remove that guy. So now I have a cursor which is inert. It's not going to interact with anything in the world. All right. I'm going to add 2 more materials into my materials folder here. And one of them, I'm going to call that the cursor. Oh my God, it's so small, I can barely read. Cursor mat. And then I'm going to make another one, which I'm going to call inactive cursor mat. Now the cursor material, I'm going to make it greenish, because why not? Here we go. And then the other one, I'm going to make it a little bit gray. And so what's going to happen with those is that in my script, in my application, I'm going to switch from gray to green when the cursor is on the cube, when it is active. And then it's going to be gray when it's not touching the cube. Okay, so now is the time to do a script, because we need to interact with our scene. So what I'm going to do, I'm going to go back to my assets, create another folder. Let's call that scripts. And inside there, I'm going to create a new script. And I have the choice between C# and JavaScript. Let's choose C#. Cursor script. And now I want this script to get started and to run for as long as the application, because the cursor is leaving the whole time. So I can attach this script to an object, for example, the main camera or the cursor itself. It doesn't matter. The main camera is going to be created as soon as the application starts. It's always there. All right? So the script is going to start running when the application starts, and the script is going to end when the application ends. Now, if I click on the camera, you see I have the script down there as a component. And this script here, oops, that's not what I wanted to do. This script here is created already. So I have a start method and an update method. Now we are going to go into Visual Studio to edit that. This guy is wrong. I'm just going to remove it. Sorry about that. Because now what I really want is generate the project so that I can go into Visual Studio and start working on my project and also build and deploy to the HoloLens. And so in order to do that, I'm going to save everything and go to File, Build Settings. And here we are going to set a few things up. I have the open scene here. So here I have the main scene. That's what I want. Then I'm going to switch to Universal Windows Platform because HoloLens is a Windows device. So I'm going to switch the platform here. Then I'm going to select a few things. I want the device to be HoloLens. I want D3D and not XAML because we are doing direct 3D. We are doing an immersive application. And I'm going to click those checkboxes just so that it generates all the files I need to do some debug. All right? Then we need to change the player settings. So let's click here. And here what I want to do is under other settings, I want to say virtual reality is supported, meaning that I can use virtual reality SDK. In that case, I'm using the Windows holographic SDK. So this version of Unity has the holographic tools installed as well. And this is what's going to take care, for example, when you move your head, that the camera actually changes and you can interact with the holograms. Okay? And finally, the last thing I want to change, down there on the publisher settings. Now, for those of you who do mobile applications, this is typically what we have in the manifest of the mobile device. So you can select your package name, your company, etc. But most interestingly, you also have some permissions. So for example, you can say, I want my application to go on internet. I want my application to use a microphone. The final application has voice command, so you can interact with it. I want my application to use spatial perception to be aware of the space around me, etc., etc. All right, so now we can generate the application. Now I did cheat a little bit because the first generation takes a long time because it's copying gigabytes, literally gigabytes of files to create everything it needs, including the player, the emulation things, etc. So I already did that step once. Normally I would create an application folder. Here it is already. I'm going to select it. And then it's going to just generate all the files that it needs. Here we go. Takes a short moment to do that. And then you can open that in Visual Studio, so you get a solution file generated, you get all the project files as well as a C# file for your script. Once it's done, you can change to Visual Studio. I already pre-opened the application. Like I said, I cheat a little bit just to go faster. All right. Here we go. Can switch to Visual Studio. It's going to ask me to reload because I had already opened it once. And now I can start doing work. And so here the most interesting thing is that you have here a totally standard Universal Windows application, including an app.cs, which is the entry point, right? If you have done some XAML development before, you would expect to see some XAML files here. But here we are doing a D3D application, not a XAML application, so we don't have those. And here I have the script, including my cursor script that I just created before. Now this is Visual Studio. You can use C#, all the tools you want. You can use ReSharper if you have it. I'm going to just reformat in a way that I prefer. One thing which may sound weird here is that we don't have a namespace, for example. Well, you see the Unity guys are game developers. They don't care about namespace and all that crap. So basically, there are a few rules that they kind of bend. Okay, like for example, one rule that they bend, they love public fields. And you know, for us serious developers, public field is a no-no, right? You have a property, yes, but you don't have a field. Well, here we do public field, and don't let that worry you, right? It's a script, it's something a little bit different. But on the other hand, we have all the beauty of C#, so this is cool. So here I'm going to interact with a cursor, which is a game object. I'm going to interact with the inactive cursor material and the active cursor material, remember the gray and the green that I created before. How do I access those? Here I'm in the script. Well, I saved, and then I go back to Unity. And here, if I go on the main camera, I have the script component down there, but now there is a change. You see I have the cursor as a game object, the inactive cursor material, and the active cursor material. So just by creating those public fields in my script, the Unity recognizes them as fields in the editor, and then I can interact with them. And so, for example, I can assign them. So I need the cursor. Cursor is on the main camera. It's here. I'm going to select the main camera, take the cursor and drag it on the game object here on the field, and now it is assigned. And then I'm going to go in my materials folder, take the cursor material, here we go, and take the gray one and put it here. Now I can save. Now I modified my scene, so I need to regenerate my Visual Studio files. In the beginning, you will do that quite a lot. But then more and more, it's going to stabilize because you're going to do a little bit more work in the script and less work on the scene. And so you're going to regenerate the scene less often. But in the beginning, this workflow is going to happen quite a lot. All right. So now it is generated. And now I can finish my script. So I'm going to go back as soon as it's done to Visual Studio. Here we go. By the way, all the changes I made before are preserved, right? So nothing changes here. Then I can continue with the implementation. So I'm going to use a gesture recognizer. And the reason why I need that is because I'm going to tap on the cubes. Then I'm going to go to the start method. The start method is executed once only when the application starts. Well, actually, it's executed once when the object to which the script is attached is instantiated. In that case, the camera. So the camera starts as soon as the application starts. So here, I'm just going to initialize my gesture recognizer. I'm going to handle the tapped event. Let's generate this method. OK? And then I just say start capturing gesture. I'm just capturing the tap in that case. Now let's worry about the update method. Update is a little bit weird because you see when you do some XAML application or some Android or iOS application, typically you react to events, right? The user clicks on something, the user types some text, and then some events are happening. Here we don't do that because this is based on the frames. So the update method is going to be executed as fast as possible, once per frame. Now if you do stuff which takes a long time here, like delay 1 second, for example, then your frame is going to last 1 second. And then you're going to fall down to 1 frame per second, which is really bad. You don't want that, OK? So movies run at around 24 frames per second. For virtual reality and augmented reality, this is way too slow, OK? We want to go up to 60 frames per second. Then we have a really good experience. If you fall down to 30 frames per second, it's still OK. But really, if you go below that, it's bad. Especially what's bad is that the spatial recognition on the HoloLens is going to fall down. And then your holograms are going to start shivering. And this is really what you don't want. Now, typically, you cannot really make your users sick on HoloLens as opposed to the virtual reality thing with motion sickness, right? Because I still see the table is still OK. It's still there. It's not moving. So I'm not going to get sick. But you're going to get maybe a little bit headaches, which, again, typically, you don't want to do that to your users. Except if you really hate them. But we do love our users, don't we? All right, so update. We are going to run that once a frame, as fast as possible. First thing we are going to do, if the cursor is null, it means something was wrong. Now I'm going to take the head position. And by the way, you see it's very small, but this is a vector 3, meaning it's a vector 3D. Now we are doing vectorial programming, vectorial algebra, and trigonometry. And finally, you understand why you sat through those hours in school. Took me 30 years, more or less, but yay, now I understand why I learned, vectorial factors and additions and all that. Then I want to take the forward direction, the forward vector, OK? And I'm going to get also the cursor renderer, because I'm going to change the color of the cursor, and we do that through the renderer. And then I'm going to use a method here. I'm going to use a raycast. So basically, from the head position, I'm going to shoot a ray in the direction of the gaze, in the forward direction. And I'm going to get some information here. If I hit a hologram, the method returns true. And so in that case, I'm going to get the object, which is a cube in that case, right, in our case. I'm going to set the material of the cursor to active, that's the green color in that case. And then I'm going to move the cursor, the position, on the point of the cube, on the point that I hit. And then I'm going to change the orientation of the cursor to match the normal. The normal, if you remember from school, right, you have a surface. The normal cursor the normal vector is the one which is pointing out. It's a perpendicular vector in all directions. So if you have a sphere, the cursor is going to come here, and then it's going to kind of kiss the sphere like that, all right, which is what we want. Now, if on the other hand we have nothing, we didn't hit anything, then I'm going to set the cursor to inactive cursor material, which is gray. Finally, because I see I'm running out of time and I really want to show you a few demos, finally, I'm going to say what happens if I tap the cube. If I tap the cube, if I don't have an object in focus, if the cursor is not on a cube, I'm just going to return, nothing happens. Otherwise, I get the rigid body, and then I switch gravity on. I say use gravity equals true. That's the checkbox that I had disabled when I did the scene. Okay? If it is already on the floor, I'm going to add some force, 100. This value is totally empiric. I tried a few values, so 100 is like a good kick, right? And in the direction of the normal, so again, if I have the cube, the cursor, I'm going to kick the cube, but not in the direction of the cursor. That would be weird because it would come to me in the minus direction of the cursor, in the other direction. Okay, so again, cursor algebra, you have a vector, a minus vector goes in the other direction. And that's it. So from here, I could say, okay, let's go and build for x86, because this is an x86. And after that, you would probably deploy either through a cable, or what is actually quite convenient, you would deploy to a remote machine, give the IP address of the HoloLens, and you can start debugging. Okay? Cool, so now I want to show you some demos. So I'm going to switch to that. And normally you're going to be able to see what I see. Now it is streaming through a Wi-Fi router, etc. So there is a little bit of delay, but it should not be too bad. I'm going to go slow. So here is what I see right now. I'm going to show the menu, and then I can start doing some things. For example, I can start putting some holograms. Here we go. And for example, let's take this guy. I'm going to make it float around. And then I can click on it because it's actually a video. So I can move around, and then you see that it is very stable, right? It doesn't move much. When I move, it stays pinned to the wall. And by the way, what's really cool is that the HoloLens remembers the room. So if I come back in 2 weeks, this guy is still going to be there. Oops, now it's right into... So what happened here is that the HoloLens needed a little moment to remember the room, and I already prepared a few things. So I have... Actually, yeah, the guy should be here, right? So I prepared it before. Now it remembers the room. The guy is here. Somewhere here I should have this guy. You probably stepped on him a few times, but it's okay. He's not angry. All right. Do we have sound? We do. Okay. Cool. Now, I also told you that you can run any type of Windows app, well, not any type, the universal Windows application without any change. That's what I told you. So, for example, here I have Twitter, and you see Twitter is pretty cool because it's running as a billboard. It has a certain depth, right? And it's very stable as well. Can reactivate it. And I'm doing something you never want to do in a session. I'm going to go and see what people say about myself. Because it is connected to my actual account, right? And so here I am. And here is René, who talked about me, and a few other things. I have Microsoft Edge. Oh my God, Microsoft Edge here on the Windows Mixed Reality web page, and so this is where you can get started for everything. All right, let me show you the application that we just developed. So this is the Holo 101, and what's going to happen is that the application starts. It is in debug mode, so it's taking a little bit longer to start, but basically it's going to tell you that it was made with Unity because I'm using the free version here. If you pay, you can change the logo. And here is the cube, the first cube. You see it's red, and you see the cursor is actually kissing the face of the cube, which is what we programmed. And now it doesn't have gravity, but if let me just check that I don't have a hole here. So now the HoloLens is basically mapping what is happening below the cube here. And if I make it fall down, it falls down. I can push it. Remember the force that we added? And then if I go there, you see it sees the feet of Mr. here, right? So basically the cube cannot go further. Well, if you do that, it doesn't move because we didn't implement that, remember? That's the thing. But on the other hand, it knows that you're here, right? Because in the real application, we didn't do that in the demo here because I went fast. But you guys get access to the source repo where you can see everything. I actually added features to say, okay, this is the ground and the holograms are going to interact. Let's add another cube. Add cube. Add cube. Okay, so this is voice features, right? So now we are going to do something which is pretty cool. I'm going to take a chair, put it down there, more or less, huh? Okay. I'm going to make sure that the HoloLens knows that there is a chair here. You see the cursor is on the chair, so that's good. It takes a couple of seconds to react to changes. And I'm going to make the cube fall down on the chair and on the floor. That's pretty awesome, right? You like it? Cool. Thank you. Cool. So that is fun. Now I'm going to show you, and I'm going to run a little bit long, but I'm sure you guys are okay with that. So I'm going to show you a few applications which are a little bit more complex and made by Valorem, the firm that I was working with before. And for example, I'm going to show you the Tire Explorer. Tire Explorer is a really cool application. We worked with Bridgestone on that, which is a tire maker, as you may know. And this is going to show you an ID when you go to a shop to buy a tire and you want to know what is inside the tire, right? So we have a few features. This is Rod.
Welcome to Tire Explorer. Okay. Before we begin, please gaze at the tire.
So in the real demo, we have an actual tire. Here it is simulated. Here it is virtual. And now we are going to open the tire to see what's inside. So here we go. You see that the details are pretty amazing, right? You have some amazing texture. It loses a little bit on the feed here. And now I can go and select one. And so Rod is going to appear. And by the way, it is a real person. We filmed him with a Kinect. And then we saved the stream, so the color and the depth. And we recorded that. We have a feature which is able to do that in real time. So basically, we can switch a flag and then have real-time communication between people wearing HoloLens over the internet. So those people can be in India, in Seattle, everywhere. Now I'm going to click here, and Rod is going to explain to me.
The body ply is the main structural material within a tire. It carries the load and provides sidewall impact resistance. Drive guard tires contain an additional reinforced rubber insert that helps the tire to resist deformation at lower air pressures. Body plies are composed of textile materials sandwiched between two layers of rubber and are the main structural material within a tire.
Etc., etc. And so you can explore the tire and learn more about that. So this is great to show to a user hidden features or maybe a model which doesn't exist yet. You saw what's happening here? It's that the device is actually mapping you guys. So this is how the device sees you, right? You're a bunch of triangle, which is always fun. Okay, I'm going to show you another application before we stop. And this application is a chemical plant. So this is an application. This is one of those which is on the spectrum that we were talking of before. So I'm going to start by putting it on the floor. And this is a model that we got from a client. And then we simplified it to make it more performant, right? So I'm going to just put it down there. Here we go. Now it's a little bit small. You hear the sound. The sound is actually directional. So if I move my head, I can hear it coming from here, right? And now I'm going to make it a little bit bigger. Scale up. Scale up. All right? Now there is a pipe inside. So now the cool thing you have to imagine, you could have collaboration between devices. Here I could have 2, 3, 5 people with the HoloLens seeing the same plant. I'm going to take the pipe out. Oops. Geez, it's a little bit small here. And let's go. No. Come on. Pipe. Okay, so I need to go down. This is very physical for a speaker. Okay, here we go. So now the pipe is kind of in the plant, but it doesn't really matter. What I want to show you is that if I click on one of the things here, I see the blueprints. Obviously, it shouldn't be inside the plant. Forgive me for that. But the blueprint is really cool because I have full HD in each eye. And so I'm able to read the blueprint and I'm able to talk about it with someone, okay? And now the other scenario that I was talking about, I want to go inside the plant, so I'm going to make it big, scale huge. All right, and now I can walk around, careful my head, okay? So this is one of those scenarios which would make more sense in a VR headset, except that here I'm happy that I know where the stage is, otherwise I would fall down. And also I can have someone walking with me and I can see that person, which is less jarring. Go up. We have a lift, because we cannot walk on the stairs yet. This is HoloLens version 5. Go up. This one is my favorite floor because there is more sun here. All right, so you see the advantage, right? You can see the model, make sure that everything is in place before actually building it. Now we have tons of other applications. The tire Explorer and the chemical plant are not in the store, but if you go and search Valorem in the store, you will see other applications which are really cool to demo. Remember I told you this is a Windows 10 device, and so I do have Office, and I have PowerPoint, and so I can finish my presentation right here. Here we go, so the demo, we saw that. This is a resource file. You will find pretty much everything you need here. Windows holographic. This is where you get started. It's on developer.windows.com. After that, the Unity tutorials. They are pretty much aimed at game developers, but you can learn a lot about 3D programming, about textures, about all kinds of things here. The Holo Toolkit is very convenient if you want additional things, like, for example, some cursor. Here we did the cursor ourselves, but typically you don't do that. You take the one from the Holo Toolkit. And finally, the repository on GitHub, where you will find the source code that we created with a lot more features, including voice command, etc. If you go to this link, that's all you need. This is what you will find. Give me just a few more hours, but you will find everything you need to get started. All right, I hope you liked it. I hope it was fun. I want to thank you very much for your attention and wish you a great end of the conference. Remember, René Schulte in Homo Sapiens if you want to go deeper in about 20 minutes. Thank you very much.